Okay, this is lesson 5-2, solving systems of equations by substitution. Okay, so on this one, you're kind of going to be plugging one equation into the other one and solving. You're substituting it in. Okay, so this first example, they give us two equations and it says solve this system of linear equations by substitution. Well, we already know how to solve them by graphing. We would get them both in y equals and graph. So now for substitution, what you do is you just start out making sure one of them is solved. It could be for y or x. On this, it doesn't matter. So this first example, this equation is already solved for y. So what we're going to do, we're going to take what they say y equals and plug it in for y on the other equation. Okay, so what that looks like, let me erase that. Forget it doesn't move with it. So what that looks like, they're going to take that negative 2x minus 9 and plug it in for y on the other equation. So this other equation is now going to be 6x minus 5 times all of this that first equation told us y equals negative 19. So then we solve. We have to distribute. Negative 5 times negative 2x is positive 10x. Negative 5 times negative 9 is positive 45. So we have this. Since these are on the same side of the equal sign, we just do what's between them. If the bell rings in just a second, it's in my video. So 6x plus 10x is 16x. Now we solve for x. I subtract 45 to the other side, and I get that 16x equals negative 64. Then I divide both sides by 16, and we get that x equals negative 4. Now, our solution is supposed to be a point, xy. So we have to now find y. So we take what we've solved for x, and now we're going to plug it into the equation that we started with. So now I'm going to have y equals negative 2 times negative 4 minus 9. Negative 2 times negative 4 is positive 8. 8 minus 9 is negative 1. So my y is negative 1 when x was negative 4. So our solution is the point negative 4, negative 1. I want you to try problems 1 and 3. Don't worry about 2. Okay, you are substituting into the other one. If you're still struggling, that's okay, because we're going to look at a whole bunch more of these. So that's in my video. So try problems 1 and 3, and then I'll go over them with you. On examples 1 and 3, we are solving by substitution. So on number 1, we have y equals 3x plus 14 and y equals negative 4x. So both of these are already solved for y. So you don't have to do anything first before you start substituting in. So I'm going to take this one because it looks a little easier, y equals negative 4x. So I'm going to take that whole thing, since that's what it tells me y equals, and plug it in for y on my other equation. So now instead of y over here, I have negative 4x equals, and then I still have 3x plus 14. So now I'm solving for x. So I have to get them together. So I'm not dividing here because I'm trying to move the whole thing to the other side. Negative 4x minus 3x is negative 7x. So I now have negative 7x equals 14. Okay, if you started the other way, that's okay. It's still going to give you the same final answers. So now I divide by negative 7. 14 divided by negative 7 is negative 2. So I have my x. So what I do, we take it, and now we plug it back into the original one we started with for x and solve for y. Negative 4 times negative 2 is positive 8. So our solution is negative 2, 8. Okay, on number 3. If you notice, this one's not solved for x or y. This one is solved for x. A lot of you maybe rearrange this one to solve for y and plug it in, because that does look probably the simplest if you want to solve for y. But since this one's already solved for x, I'm going to take that and plug it in. So I'm going to take what it tells me that x equals and plug it all in for x on the other equation. So I have 4 times x, but now instead of x, I have 6y minus 7 plus y equals negative 3. Okay, so if you're still confused on this, don't worry. We're going to talk about it in class tomorrow too before we start the assignment. So first thing we have to do is distribute. 4 times 6y is 24y. 4 times 7 is 28 plus y equals -3. Okay, I have 24y here plus y here. So I'm going to just do those because they're on the same side of the equal sign. 24 plus one more, I have 25y minus 28 equals -3. Now I'm solving for y. I get rid of the 28. Let's see, -3 plus 28 is 25. Then I divide. So y equals 1. I take that and plug it into the one I started with so I can solve for x. I'm going to come up here. X equals 6y minus 7, but now instead of y, I'm going to plug in 1. 6 times 1 is 6. 6 minus 7 is -1. So our solution on this one is the point -1, 1. Okay, example 2, we're doing the same thing. Okay, so this first one has -x plus y equals 3. 3x plus y equals -1. So neither one of them are solved for anything. So we first have to rearrange one of them, it doesn't matter, to solve for x or y. So again, doesn't matter which one you solve for either. So what they did was they solved for y on this one because all you have to do is add x to the other side. So y equals x plus 3. So once we've done that, I take this and plug it in for y on the other equation, since that's what it tells me y equals. So we now have 3x plus x plus 3. It is important to put it in parentheses, just because sometimes a minus or a negative throws everything off. So since it's just plus and then x plus 3, these parentheses aren't as crucial. So I have 3x plus x, which is 4x plus 3 equals -1. Now we solve for x by subtracting 3 to the other side and then dividing both sides by 4. So we get that x equals -1. So I take that, since I've already plugged into this equation, we now take that and plug it into the other one. So you can either plug it in where it's already solved for something or how it originally was. Those are the same thing, just different order. So I'm going to plug it into this one because it'll tell me exactly what y equals. So I have negative. Okay, so now it's a negative. Okay, they plugged it into that one. I would have plugged it into this one. Doesn't matter. -1 plus 3 is 2. So they plugged it into the original. So there was a negative there. Then it's -1. So a negative and negative cancel and make a positive. So they said, okay, well, 1 plus y is 3. Subtract 1 over to get 2. So our solution is -1, 2. Okay, so I'm going to have to erase this so you can see the problems. I am going to go over, again, how to plug it in your calculator. When you're plugging in your calculator, that's just a way for you to check because you still need to know how to do these different ways. But plugging in the calculator is by graphing it just to check your solution. So we're going to do these right here. So how you do that, and you can reference the video I posted yesterday if you need to. But you go to your y equals, clear anything out that you have in there, and you're going to type those two equations. Y equals x plus 3. And then on a y2, put y equals -3x minus 1. What you do next is hit graph, and it'll pull them up on your graph. Then you hit second trace up at the top, and you have to go down to intersect. Mine is number 5. Yours might be 4 or 5. Then you have to hit enter where it says first curve, hit enter through second curve, and hit enter where it says guess. And it says intersection x equals -1, y equals 2, which is what we got, -1, 2. Okay, so I want you to go ahead and try all 4 of these just to get good practice. I know they take some time, but try all 4 of these. I'll go over them with you, and then that's going to be the last 4 we look at. Okay, on these last 4, I'm going to do 2 of them, erase it, and then do 2 more since I don't have a ton of room, because these problems don't take just a little bit. They take a lot of work. So I do want to start out by saying whatever I solve for, on the board doesn't mean that that's the only way you can do it. Technically, there's 4 different ways to start these problems. So if yours is not exactly like mine, just keep watching because you still may have the final answer correct without doing it the correct order or the same order as me. Yours still could be correct. Okay, so with that being said, on this problem, nothing is solved on either equation. So we have to solve one of them. So that means I could solve for x and y here, or I could solve for x and y here. So what I'm going to do, I'm going to solve for y over here. That may not be what you did, and that's okay. So on this one, I'm going to add 3x to the other side. Now here's my 2 equations. I'm going to plug this in for y on the other equation. So x plus y, but I now have 6 plus 3x equals -2. There's nothing to multiply or solve in parentheses, so I can just drop them. This is 1x plus 3x. That is 4x. So now I can finally solve for x. Subtract 6. -2 minus 6 more is -8. Last step is to divide by 4. And my x is -2. I take that. Now, since I rearranged this one, I have 2 options. I can take this x and plug it in to how I rearranged it, or up there. That part doesn't matter because those are the same equations. I just rewrote it to be solving for y. So I can plug it into either one of those. So I'm going to plug it into this one since it's already set up to solve for y. 3 times -2 is -6. 6 minus 6 is 0. That is still a point. -2, 0. And even if you worked it out differently, you should have still gotten that solution. Okay, next one, number 5. I wanted y'all to get good practice at this. Again, this one is not solved for anything, so we're going to have to rearrange one of them to solve for x or y. Doesn't matter. So I'm going to solve for y on this first one. And then plug that in for y on my other equation. Now, this problem is a good reason why we have to put parentheses, because it's minus out front of those parentheses. So that technically is being distributed in. So I have 4x plus 4 minus x, all because it was minus the whole parentheses. Okay, so now I have 4x minus 1x, so 3x plus 4 equals 10. Subtract that 4, and I get 3x equals 6. Last step is to divide, and I get that x equals 2. So I take that, plug it in for x on the other equation. That's pretty simple. -4 plus 2 is -2. So my solution is the point 2, -2. Okay, let me erase this, and then we'll do 6 and 7. I got them wrote down for myself. Okay, problem number 6. Okay, problems number 6 and 7. So on 6 and 7, neither of them are solved for anything, so we have to solve first. So I think it really doesn't matter. I'll solve for y. So I'm going to solve for y on this one. So I subtract 2x then I have to get rid of that negative. I've just now got it to where now I can substitute. I take all this, plug it in for y on the other equation. So I'm going to come down here. So 3x minus all of this equals 1. So again, I have a minus out front of the whole parentheses. So it changes the sign of everything in there. So I have 3x minus 2x, so I just have 1x. And then add 5 to the other side, x equals 6. I take that, plug it into my first one. That's why I draw arrows, so I can remember which one I plugged into what. Because it does get confusing when you get down to there and you can't remember which one you started with. So x equals 6 goes into my first one. Two times 6 is 12. 5 plus 12 is 17. So 6, 17 is our solution on that one. Okay, on number 7. Let's see, I don't even know what I want to solve for. I'm going to solve for x on this one just because that looks pretty simple. One step to move that over. So it's solved for x, so I'm going to take and plug this in for x over here. So 3 times x, which is now all of that, minus 2y equals 3. So I have to distribute here. 3 times 7 is 21, minus 3 times 2y is 6y, and then I have minus 2y equals 3. So this is a negative 6y minus 2 more y, so 21 minus 8y. So I get rid of that 21. Three minus 21 is negative 18. This does not come out to a nice number. I'm wondering if I wrote it down wrong. Let's see. Negative divided by negative is positive. 18 divided by 8 is 2.25, or 2 1/4. So I guess we'll leave it like that. If I messed up, I'm sure y'all will figure it out, but I don't think that I did. If I messed up, I bet I just wrote the problems down wrong. So I'm going to plug that in for y. So 2 times 2.25. So that's going to be 7 minus 4.5. So x is 2.5. That could be right. You can get decimals. It's points, so that makes sense. It's the point where they intersect on a graph. So it might not always be on whole numbers. So I got the point 2.5, 2.25. Okay, so I think that is all we're going to look at today.